Okay, so you look at this and it's just like there's so many natural logs. So the first thing that I would just really emphasize is what is the different respective factors. So this x is a factor, this is a factor, this is a factor. So you have these three separate factors and then you're integrating that all in the denominator. So obviously we are going to have to pick a u and a du. There's two ways of doing this. You could just say I'm going to pick the u as natural log x, the quantity in parentheses. Then our du would be 1 over x. And I think that honestly is how most people would approach it. They just say, let me pick u, natural log x. So if I use that as my little key for the substitution, what I would have, using the first u is equal to natural log x, this natural log here would become a u, and this natural log would become a u. So I would have a u there, natural log of u, and I would still have the x, and I would still have the dx. So again, this natural log is becoming a u, this natural log inside here is becoming a u. All right, then I could go to the second step of replacing my du definition, and I apologize, this of course needs a dx here. So using the du definition, I could say that this dx over x, all of that becomes my du. So this, let me do this in a different color. So this dx over x, that would become du. And that's over my u natural log u. And then we have the integral. Now, you look at that and it's like, well, how am I going to integrate that? Because I don't have a special little rule for u natural log of u in the denominator. So to integrate this, we would have to think about doing substitution again, because we can't integrate it with just our given formulas. So remember, for substitution, we want u and its derivative to appear inside of the integral. So we talked about this in the previous example. We're not going to pick just u. We're not going to pick just x as the u, quote unquote. And what we're going to do here is we can't talk about u still because we're doing another substitution. So for the second substitution, what I'm going to do is I'm going to define w. So I'm going to let w be natural log of u. And then my dw would be 1 over u du. Now, with that key in mind, I would make my appropriate replacements. So this natural log of u would become a w in the denominator. Okay, so natural log of u here becomes w in the denominator. That leaves us with du over u, which would become dw in the numerator. And then we can integrate. Now, when you look at integrating this, you say to yourself, oh, I have a w to the first power. And anytime I have w to the first power, x to the first power, u to the first power in the denominator, so I have a variable to the first power in the denominator, that is going to go to this natural log absolute value function. So this, when I just have 1 over that w to the first, that becomes natural log absolute value of w plus c. So we substituted and now we have integrated. And after I integrate, remember I have to substitute. Now we made 2 substitutions here, so we're going to have to make 2 substitutions back. So this is going to get a little complicated, but we're going to be fine with it. So the first substitution, we'll substitute what w is. So w was natural log of u, and then plus c. Then the second substitution, we're going to use the fact that our u was equal to natural log x. So up here, we had u is equal to natural log x. So we'll have natural log, absolute value, natural log, and then in for our u, we are going to plug in natural log x, absolute value, plus c. And that would be our final answer. So we have lots of natural logs in there. There's 3 natural logs. And again, that's doing 2 u substitutions. I do want to mention just one thing in case you were thinking about this. You could go through this problem and pick u is equal to natural log x. So the most complicated thing. And if you did that, then your du would be 1 over the argument to start. So that would just be natural log x. And then the derivative of the argument, natural log x, would be 1 over x. Okay, so that would give you that your du is 1 over x natural log x dx. And then what you could do is you could say that all of this dx over x natural log x, that becomes my du over, and then natural log of natural log x becomes u, and then we integrate that. So that would be another way of doing that. Again, you're going to get to the same conclusion because here when I go through this, I will have natural log of u, and then I'll substitute in absolute value, of course, plus c, and then I'll substitute in what u is equal to. So you get the same thing, but it's all about what makes you happiest. But it is really good to do the 2 substitutions just to kind of see how that would go, because sometimes you're not going to pick the right u, and you are going to end up with a 2 substitution situation.